Welcome to Brain Vision.
For this question, we're considering a solenoid that has a diameter, we're considering a copper wire, which we're treating as a solenoid, I should say, that has a diameter d of 2.5 times 10 to the minus 3 meters, since it's 2.5 millimeters. So therefore, the radius would just be simply d over 2, of course, and the current it's carrying, I, is 33 amperes. For part A, it wants us to find the magnetic field at the surface of the wire. So let's indicate this as part A first before we start working. So the magnetic field at the surface of the wire, B, in this case, is going to be equal to mu naught times I divided by 2 pi times the distance we're considering here. Well, the distance we're considering here is the radius, r, from the center. So we plug the values in to this expression. Remember, mu naught is 4 pi times 10 to the minus 7 newtons per ampere. It's the magnetic permeability of free space. Plugging those values in, we find that this is equal to 5.28 times 10 to the minus 3 Tesla, or 5.28 millitesla. So you could write it as 10 to the minus 3 Tesla or millitesla, up to you. They mean the same thing. For part B, we're asked to find the magnetic field inside the wire at a distance 0.5 millimeters below the surface. Okay, so we have, in this case, B is equal to mu naught times I divided by 2 pi. And this time it's going to be multiplied since we're still inside the wire, but we're a distance of 0.5 millimeters below the surface. We have the distance we are below the surface, which is r minus 0.5 times 10 to the minus 3 Tesla, or r minus 0.5, or excuse me, not Tesla, meters. 0.5 millimeters, or 0.5 times 10 to the minus 3 meters. So that's the distance we are below the surface, or the distance from the center would be r minus that value, divided by the total distance to the surface, r squared. Okay, so plugging those values into this expression, we find that this is equal to 3.14 times 10 to the minus 3 Tesla, or in other words, 3.14 millitesla. And then for part C, we're asked to find the magnetic field 2.5 millimeters above the Earth's, or not the Earth, excuse me, 2.5 millimeters above the surface of the copper wire. So again, 2.5 millimeters is the same as our distance d, but just coincidentally here. So what this magnetic field B is going to be equal to is mu naught times the current I divided by 2 pi again. And this time it's multiplied by the distance d that we are above the surface plus the distance we are from the center. So we need to include the distance from the center of the copper wire to the surface in addition to the distance from the surface to the point we're considering. So this is going to be r, because that's the distance from the center to the surface, plus the distance from the surface to the point we're considering is 2.5 times 10 to the minus 3 meters. Redraw that in. There we go. And let's extend this to put it all in the denominator. Plugging those values in, we find that this magnetic field is equal to 1.73 times 10 to the minus 3 Tesla, or 1.73 millitesla. And we can box that in as our solution to part C, and that's the final part of our question.